Good morning, Year 7. I hope that you're all doing well at home and you're keeping safe. So for today's lesson, you will be learning about pH. But before we start the lesson, you need to make yourself familiar with these symbols. So you can see over here, you have the pause button. Whenever you see this symbol, when I tell you to press pause, you press pause, you do the task, and then when you finish the task, you press play again. You will also see a timer symbol. This timer symbol means that I have set you a time limit for each of your tasks. I would suggest you use your phone or a watch and actually stick to these times, because if you don't, sometimes you'll spend way too long on a task and you'll find you won't have time to do all the work. Then, if you see a pen symbol, this means I want you to write down your answers. If you look on Teams, there is a Word document there that I would like you to put all your answers on. And then I will check your work later to make sure that you've done it properly and you understand. Okay, so this is going to be your do it now, like you do in school. What I would like you to do is, I would like you to have a read of the statement. Then you are going to pause the video and you are going to write down on your whiteboard any answers that you have. So pause the video now, please. Okay, brilliant. What you are going to do now is, as we go through the lesson, you're going to see whether your answer is correct or incorrect. So the big question today is, can colours warn you about hazards? So we have discussed acids, but now we're going to talk about acid strength. So as you can see in the picture, you have different acids. You have balsamic vinegar, lemon juice, sulfuric acid, which is an acid that we use in the laboratory, yogurt, which is made out of milk, which is lactic acid, then we have strawberry jam. What I would like you to do is have a think, rank these in order from the weakest to the strongest, please. And then as an extension, I would like you to justify your answers, which means explain why you've chosen that answer. So press pause now. Okay, so what I will tell you is at this point that if you said sulfuric acid, you'd be right. That is the strongest acid. But we're going to look at the pH scale, and I'm going to show you what a strong acid is on the pH scale. So as you can see on this slide, we have a pH scale. The first thing you notice is that there is a wide variety of colors. Colors makes everything easier to see. So if you see a color, you know exactly, oh, it's red, so it must be pH 1, which means it is a strong acid. Oh, look, it's green, a light green color, which means it's neutral, which means it's neither an acid or an alkali. Or if your sample has bright purple color to it, you know that is a strong alkali. So the strength of an acid or an alkali is measured by this pH scale. It also allows solutions to be ranked according to their acidity, over here, all the way to their alkalinity. And the pH value, which you can see is 1, 2, 3, 4, can be found using something called a universal indicator. We will talk about this next lesson. Each color represents a number relating to the pH value. So, how do we identify acids and alkalis? We use indicators, as I suggested. So why is indication of strength more useful than simply knowing if a substance is acidic or alkali? So if I told you, oh, I have a liquid here and it's acidic, you have no idea if it's a strong acid or a weak acid. And if you don't know, you have no idea how to handle the acid. So we use indicators. They're actually just colored dyes, like the dye that you'd use to dye your clothes. And they change color depending on whether you have an acid or an alkali mixed with it. So what I would like to do now is, if you have your whiteboard, we're going to play a game. It means higher or lower. So you're going to write down whether the substance is higher pH or a lower pH. So now you need to know what a high pH is and what a low pH is. So in your answer, you're going to include the pH and the indicator color. For example, banana, we know it's pH 5, so it's actually a weak acid. Now, I would like you to write on your whiteboard, battery acid. Do you think it is a higher pH or a lower pH? And then tell me the color on the pH scale. So I would like you to pause the slide, set your timer for 1 minute, and write down your answers on your whiteboard. So pause now. Okay, so let's see how you did. So battery acid, higher or lower pH? So it is actually a lower pH. It is pH 1, which means it is the red indicator color. Beer, higher or lower than battery acid? It is pH 4, so it is actually a higher pH, which means that it's actually the orange color. So if you put an indicator in be an indicator, it would be orange. Bicarbonate of soda, it is pH 8, so it is actually a weak alkaline, so it would be this dark green on your pH scale. Now let's move on to the next one, higher or lower. I've started again and I've given you a star in pH. So we have bleach. Bleach is pH 13, so it is extremely strongly alkaline. Now, look at the next solutions and decide whether they are higher or lower. So, press pause, set your timer for 1 minute and write down your answers. Okay, so let's have a look. If we have a look at blood, what do we think? Higher or lower pH than bleach? It is actually a lower pH, and you can see it is almost neutral, almost 7. So it's pH 7.5. What about Coke? You drink every day. What do you think it is? It is actually pH 3, so it's actually a strong acid. And this is why they say you shouldn't drink too much Coke, because the acid will destroy your teeth. Now we're moving on to drain cleaner. Higher or lower pH? It is actually extremely strongly alkali. If you look on the pH scale, it is purple. So it's actually hazardous as well. Because remember, strong alkalis and strong acids are hazardous. They are corrosive. They will eat metal. Okay, let's have another go. So again, I'm starting with hand soap. It's pH 10. So it's actually alkaline. And remember, we know things are alkaline because they have a soapy feeling to them. So I'd like you to now pause the video, set the time for 1 minute, and write down your answers for the rest of them. Okay, so lemon juice is a lower pH, pH 2. Milk, remember milk is actually an acid, but it is a weaker acid than lemon juice. It is pH 6. Pure water, now what do we think pure water would be? Pure water is actually pH 7, which means it is neutral. It is neither acidic or alkaline. And if you use an indicator, it would be green. Now, the last one, just to get you practicing these. We have saliva. The saliva in your mouth that helps during digestion is actually pH 6. Seawater, higher or lower? So pause the video, set the timer for 1 minute, and write down your answers, please. Okay, so seawater, pH 8. So seawater is actually slightly more strongly alkaline than pure water. Then we have stomach acid. So this, remember, stomach acid doesn't help to break down food, but it kills bacteria. Your stomach acid is pH 2. That is how strong your stomach acid is. It is a very, very, very strong acid over here. Okay, so now what I would like you to do is, if you open up the Word document on Teams, you are going to find some exam questions. It's always good to do exam questions to get you practicing now, because you're going to have to do your GCSEs. The more practice you get, the more used you'll get to them. So what I would like you to do is, once I finish discussing how you do it, you are going to pause the video, set the timer for 6 minutes, then write down your answers on the Word document. After 6 minutes, you are going to press play again. Then I'm going to tell you all the answers. You are going to correct the answers using a different colored font, just so I can see which ones you've done really well on and which ones you need to improve on. So I would like you to press pause for 6 minutes and have a go at this first task. Okay, brilliant. So, for 1A, which soil sample is neutral? That answer is C. Because remember, C, pH 7, is neutral, neither acidic or alkaline. B, part 1, most types of heather, which is a type of plant, grow better in acidic soil. In which of the soil samples should heather grow well? So this question has given you information, acidic soil. So you can say A or D. If you said either of these, you would be correct. Part 2, cabbage grows better in alkaline soil. So the question is giving you information. In which of the soil samples should cabbage grow well? If you said B or E, you would have got this correct. Well done. So, question 2. From the information in the chart above, you need to answer the questions. So, A, part 1, a substance which is almost neutral. You could have said either soap with moisturizers or normal face wash. If you said either of those, you'll be correct. You can see it says do not accept soap or pH 7.3. You have to be very specific when you're answering in science. The next one, the substance which is most alkaline. If you said normal soap, excellent. You've got that correct. And then part B, tick one box, describe Johnson's facial wash. You want to say it is slightly acidic, because you can see it has a pH of 5.5, which means it is slightly acidic. Okay. So going back to the big question, can colors warn you about hazards? Think about what you've just learned and try and answer that question in your head quickly. Okay. So, why do we have a pH scale? And why is it used? So, it is used every day. Farmers test the pH of their soil because, for example, heather only grows in acidic soil. If you had a very highly alkaline soil, the heather won't grow. So farmers need to test the pH of their soil to make sure that the plants they're growing will grow strong in that soil. So they would use a pH scale. Scientists use it. researchers need to make sure their solutions are the correct pH when they're conducting an experiment. Because, for example, they might have an enzyme. So this is a chemical that helps to break down certain substances, for example, your food. But some of them only like to be in, for example, a very strong pH, like pH 1. So if you put them in pH 8, they're not going to be able to do their job. Or a bee sting. So bee stings are actually acidic. So you need an alkaline to treat them. And when you treat the bee sting with something that's alkaline, you make it neutral, which is pH 7. So what I would like you to do for this next task, this is going to take you a bit of time. If you look on the Word document that you just did the exam questions on, there is a pH scale already placed on there for you. I want you to first of all label the pH scale. The keywords you need to put on there are neutral, strong, acid, weak acid, strong alkali, weak alkali. Use arrows to point to the different sections of the pH scale. That is the easiest task. Then you have a 2 chili task, a little bit more difficult. Write a guide for using the pH scale. In it, you need to say how you would find, for example, a strong alkali. Give me as much information about the pH scale as you know now. And then the hardest, or the most challenging, is 3 chilies. I want you to explain how you would use the pH scale to assess the danger of a substance. Would there be enough evidence? So you are going to aim to do all 3 chilies. You want to aim high. So if you could do this on the Word document, if you find that too difficult, you can do it on a piece of paper, and bring it in when you're back in school. Okay, so I would like you to pause the video, set your timer for 15 minutes, and write down your answers. So pause now. Okay, brilliant. I'm looking forward to seeing all your amazing work. So we have the last task, which is going to be a fit task. Fit task means silence. So if you can, try not to talk to anyone during this time. So it's like a mini exam. So on the Teams Word document again, you will find these questions at the bottom of the document. You are going to read the exam questions, then you are going to answer them. You can see I've said set the timer for 5 minutes. This is because in a test, 1 mark means 1 minute. So they think that if you have a 1 mark question, it should take you 1 minute to answer that question. So once I have finished talking, you are going to pause the video, set your timer for 5 minutes, write down your answer on the Teams Word document, then you're going to press play, and then we are going to go through the answers together. Okay, press pause now. Okay, brilliant. So the first one, it says the graph below shows how the pH of the liquid in Barry's mouth changed after he ate a meal. So when he started to eat, the pH was 7. Then you could tell over time what's happened to the pH. It's decreasing. So use the graph to give the pH of liquid in Barry's mouth before he started to eat. So you look at your graph. Your graph gives you all the information you need. You can see Barry started to eat. If you go across, you can see that is pH 7. So your answer should be pH 7. If you put neutral, unfortunately we cannot accept that answer. It's asking you for a pH number. The next question. What does this pH tell you about the liquid in Barry's mouth before he started to eat? We know that pH 7 means it is neutral. So if you said it is neutral, well done. Look at the graph above. What happened to the pH of liquid in Barry's mouth as he ate the meal? So you want to say any one of these. You can say it decreased, it went down, it became acidic, or more acidic. If you said it dropped to 5, that would still be the correct point. And then part C, Barry chews special chewing gum after each meal. The chewing gum neutralizes the liquid in his mouth. What type of substance neutralizes an acid? So think back to when I told you about the bee sting. So bee sting is acidic, and we use an alkali to neutralize it. So if you said the answer alkali, you would have got it correct, because remember, it neutralizes neutral. It brings it to pH 7. Okay, perfect. So that is the end of today's lesson. If you need any extra help, please get on Teams. I will reply as soon as I can. I would like you to also make sure once you've done the work on Teams, you need to press submit. If you don't press submit, I can't see your work and it registers that you haven't done the work. Okay, good luck and please stay safe, look after yourselves, and hopefully we'll see you soon in school. Okay, bye.